Hello everyone, welcome back to my channel. So today we are going to discuss another problem, but before going forward, if you've not liked the video, please like it, subscribe to my channel and hit the bell icon so that you get notified whenever I post a new video. So without any further ado, let's get started. Problem uh, is majority element. So in this problem we'll learn a new concept, so stay tuned. Uh, in the problem we are given array of size n and we need to return the majority element. Now, what is majority element? Majority element is that element which appears more than n by 2 times. Means n is the size of array. And if there is any element that appears more than n by 2 times, then that element is a majority element and we need to return that. And we may assume that majority element always exists in the array. So there will be always an element whose count is greater than n by 2. So we have to return that element. Let's take this test case. So see guys, over here we have to find majority element. We have to find majority element. And what is majority element? A element that has count more than n by 2, where n is size of the array. Now over here if we see size of the array is what? Like let me do indexing 0, 1, 2, 3, 4, 5, 6. So size of array is 7. So 7 by 2 will be what? 3. We will take the integer part 3. So we have to find an element whose count is greater than 3. Count should be greater than 3. So over here if you see, we have two elements in this array. One we have whose count is what? 1, 2, 3. 3. And 2 we have whose count is what? 1, 2, 3 and 4. So we have to find an element whose count is greater than 3, right? N by 2 means greater than n by 2. So here 2 is the element which is occurring more than n by 2 times, more than 3 times, which is 4. So 2 will be the output. 2 will be the majority element. So always there will be the majority element in the array. They have provided that in the problem. See, always there will be majority element. So one brute force approach, see guys, which comes into mind directly, wherever there is count, we have to find count and we have to do something with the count. Obviously, we can think of using hash map. We can use an ordered map or hash map, and we can store the count of each element, and then we can simply see which element has n by more than n by 2 count, more than n by 2. So let's quickly discuss that approach also. Then we will see the optimized approach for this problem. So here it was 2. So see, whenever there is count, we have to do something with the count. We have to find count and do something. So hash map is the best data structure to store count. So we'll use another map, or you can say hash map. And what we will do is we will traverse this array and we will be storing the count of each element. So here key will be the element and value will be count, its count. So this is your key and this is your value. So 2 is the key and currently initially its count we will write as 1. Then we go ahead. So we again get 2. Again 2 is in the map. So what we will do is we will increment its count. Then we go ahead. Now 1 is not in the map. So 1 we will add and initially we will add its count as 1. Then we go ahead. 1 again it's in the map. Increment its count. Then again 1 is in the map. Increment its count. Then we get to 2. 2 is in the map. Increment its count. Then we go ahead and then we get 2. So what we do is we increment its count. 2 was in the map, so we increment its count. So over here, once we have traversed this entire array, we have all the counts of each element, and then just we simply iterate in this map and we will find out which element has count greater than n by 2. So here 2 has count 4, which is greater than n. N is 7 by 2, that is 3. So 4 is greater than 3, hence 2 is the majority element. Alright, So this is one approach. Time complexity for this will be O of n, single traversal in the array, and then we are going through this map keys. And space complexity again will be O of n, because we have this map, unordered map or hash map. Alright, so this is one approach. But in the problem they have said, as we can see here, follow up is that we have to solve this problem in linear time and constant space, CO of one space. Linear time though we are doing, linear time we are doing, but this space we are using, this hash map, this is the extra thing, extra. So this we need to remove, this we need to eliminate, right? So now let's see the optimized approach for this problem. Now this optimized approach, to be honest, is not intuitive. If you are doing it for the first time, you will not think about it. You might get an intuition, but not entirely you might get it. So that is a concept which you need to know earlier in order to approach further in future problems. So let's see that concept. The name of the concept is Moore's voting algorithm. Let's see what that is. So for that now, what I will do is I will copy this code and we will dry run the code, and then we can better understand. So once we dry run the code, you will better understand how it's working. So just a second, like that. Okay, so see, what we do is, this array is given to us, right? What we will do initially, we have to find the majority element, that is element which occurs more than n by 2 times, right? More than n by 2 times. So for that we will take two variables. One variable will be count. Initially it will be 0. First see guys, we'll dry run and then we will understand how it's working, right? And then we will have res is equal to 0. Okay, so see, we will start iterating on the nums array. So first of all we'll go to this element 2. So num has 2. We will see if count is 0. Count is 0, yes, count is 0. So num, assign it to res. So num is what? This is num, right? This is num. Assign it to res. So now res will become 2. Okay. Now we go to this if. We check, is num not equal to res? What is num? Num is 2 and res is what? 2. 2 is equal to 2. So it will go in else. And count plus plus. So count will increment. What does this mean? This means that two element, this 2 number which is in the res, has right now we have encountered it one time, right? One time. Okay, now let's go further. So let's go further, and over here now num will go to here. Num will be this number. Now we'll see if count is equal to 0. No, count is 1, so it will not go in this if. Now we'll check, is num not equal to res? Num is 2 and 2 is not equal to 2, so that condition is not true. It will go in else. And count plus plus. So again count will be 2. That means 2 element we have encountered 2 times as of now. Okay, now let's go ahead. So now num will go over here, num will come here, right? Now over here we will again check, count is equal to 0. Is count equal to 0? No, count is not equal to 0. So we will go in this if and we will check, is num not equal to res? What is num? 1. What is res? 2. So 1 is not equal to 2. This is true. So this if condition is true, so we'll go in this if. So we will do count minus minus. That means now we will decrease count. Okay, that means now we have this one, so we have decreased its count. Okay, so now we'll go ahead. We go ahead. So let's go over here to this one. Now again we will check, is count equal to 0? No. is num not equal to res. What is res? 2. And num is not equal to res. So it will go again in count, this if and count minus minus. That is, it will decrease to 0. Okay. Now what we will do? We will go ahead. So num will go ahead. Num will come here. Num. Over here we again see is count equal to 0. See, now count is equal to 0. Count is equal to 0, right? So what we will do is, we will over here, we will write res is equal to, we will write res is equal to num. So num is 2. So res will become 2, right? So it will get updated and it will become 2. And then we will check is num not equal to res. So num is 2 and it's equal to res. So we will increase count. And then we go ahead. And then what we do? This will be, now num is here. So count is not 0 and num is equal to res. So count will increment. So at last, see, we have traversed the entire array. We have traversed the entire array. And we have found, at last we can return res because that will contain the majority element. This will be the majority element. Right, so see why this approach is working. Because see, obviously majority element will always be greater than all the other elements. So as in its count will be greater than all the other elements counts. So at last, in the rest, we will be having the majority element. Because all these calculations will, see, this count will be always greater. Majority elements count will be always greater. So after you do this, after you complete this loop, right, rest will have the majority element. So let's do one thing. Let's try run another test case. It will become more clear. So let's take another test case. So we can take 3, 3, 4, 3, 3, 4 and 2, 4, 4, 2, 4, 4. Okay, so this test case we can take, and over here majority element will be, I guess, 4. So 3 is occurring how many times? 1, 2, 2 times. 2 is occurring how many times? 1, 2, and 4 is occurring 1, 2, 3 and 4. No, 1, 2, 3, 4, 5. 5 times. And the size of this array is 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 is the size of array. So 9 by 2 will be what? 4. Right, 4.54. So 4 is the only element whose count is greater than this 4. So 4 will be the majority element. 4 will be the majority element. Now let's see how this algorithm is working in this case. Okay, so let's dry run. So I will highly recommend first you pause the video and do dry run yourself, and then you can continue watching. So we have res is equal to 0 and count is equal to 0. Okay, so see, first of all we start from here. This is our num, right? This is our num. Initially count is 0. Count is 0. So we will assign this num value to this res. So res will become 3. Now num goes ahead. And and this count, because num is not equal to is equal to res. So here count will also increment. This one. So again we go here and count is not equal to 0 and num is equal to res. 3 is equal to 3. Okay, so count will increment. Now we go ahead. It will counterbalance when they are not equal, so it will counter these elements, these values. So here now we have 4. So count is not 0. This is not true. But num value is not equal to res. 4 is not equal to 3. Then what we will do? We decrease the count. And we go ahead. Okay. Now see. Now we have count is still not 0. And num is 2, which is not equal to res 3. So again count will decrement. 0. We go ahead. Num. And then what we have? We have 4. which is see, count is now 0. We go here, count is 0. So we will assign this num value to res. So res will become what? 4 num. And then we check, is num equal to res? 4 is equal to 4. So count will increment and it will become 1. So you see, it's counterbalancing. It's counterbalancing the values. Whatever the majority element, eventually it will come in this res. Now we come here to this. Now count is not 0. So and num is equal to res. So count will increment. Then we go ahead. So here count is not 0, and then but num is not equal to 2 is not equal to 4, which is res. So we will do what? Count minus minus. So 1. Now it will become 1. We go ahead, and here count is not 0. So but num is equal to res. So count will again increment. And then we go here, and this will be we have over here count is not 0 still, and num is equal to res. Num is equal to res. So count will increment. Right. So see, at last, once we are completed with this loop, in the res we will have the majority element. Alright. So that we can return. So output will be 4. So guys, see, I hope you understood this approach. This is a concept called as Moore's voting algorithm. So what is happening over here is the majority, the element which has most greater count will come in this variable at the end, because we are counterbalancing the count using this algorithm. Just dry run once this algorithm, you'll better understand. So I hope you understood the problem and the approach. So the code will be given in the description, C++ and Java code. So it's exactly same what we have dry run. Let me know in the comments if you have any doubt. And time complexity is O of n. See, we are doing single for loop, and space is constant because we are not using any extra data structure. We are just using variables. Right. So if you found this video helpful, please like it, subscribe to my channel, and I'll see you in the next video.